The floor planks beneath Tobias Whitlock's bare feet radiated heat like sun-warmed stone, though outside his cabin the Wyoming winter held at 18 degrees below zero. Silas Pemberton stood in the doorway, jaw slack, watching his neighbor walk comfortably in shirt sleeves across a floor that should have been frozen solid. Before we dive in, let us know where you're watching from, and if stories like this move you, hit that subscribe button, because tomorrow's episode is even more unbelievable than this one. The year was 1842. The Wyoming Territory stretched wild and unforgiving across land that would not see statehood for another 48 years. Men and women who settled there understood the bargain they had made. Freedom and opportunity came at the cost of isolation, danger, and winters that killed with methodical efficiency. Tobias Whitlock had accepted these terms when he claimed his 160 acres along the tributaries of the Sweetwater River in the spring of 1839. He was 28 years old then, newly married to Catherine, a minister's daughter from Pennsylvania, who had chosen frontier hardship over eastern comfort. They built their cabin that first summer, using techniques Tobias had learned from his father in Virginia. The structure was solid by frontier standards. Logs, hewn from ponderosa pine, notched at corners with careful precision, chinked with clay and moss that sealed against wind. The cabin measured 16 feet by 20 feet, with a stone fireplace Tobias had built using river rock and clay mortar. A single door faced south. 2 small windows, covered with oiled paper in winter, let in light during summer months. The roof was split shake shingles, laid thick enough to shed snow and rain. Inside, Catherine had created a home. A rope bed frame held a mattress stuffed with prairie grass. Shelves lined one wall, holding their modest possessions. A table Tobias had built from hewn planks stood near the fireplace. 3 chairs, because by 1841 there were 3 of them. Gideon arrived in March of 1840, a healthy boy with his mother's dark hair. Meredith followed in September of 1841, smaller but equally strong. The cabin that had seemed spacious for 2 adults now held the sounds of children, the smells of cooking, the accumulated evidence of a family building a life in wild country. Tobias worked hard. He had claimed bottomland near the river, soil that would grow wheat and vegetables during the short growing season. He hunted elk and antelope to supplement their supplies. He trapped beaver and fox, selling furs at the trading post Owen Blackwood operated 40 miles east. The work was endless, but Tobias thrived on it. He was competent, careful, and strong enough to handle the physical demands of frontier agriculture. Their first 2 winters had been manageable, cold, certainly, but Tobias kept the fireplace burning, and Catherine was skilled at cooking. Meals that stretched their supplies. They had enough firewood stacked against the cabin's north wall to last through the frozen months. The children were healthy. Life was hard, but good. The winter of 1842 began normally. October brought the first snows. November saw temperatures drop steadily. Tobias prepared, as he always did, ensuring they had ample supplies, sufficient wood, and the cabin sealed tight against coming cold. He had no reason to expect this winter would be different from the previous 2. He was wrong. December arrived with temperatures that dropped below anything Tobias had experienced in Wyoming. The cold came down from the north in waves, each one colder than the last. By mid-December, morning temperatures held at 20 below zero. By late December, the thermometer Tobias kept outside the door registered 32 below on 3 consecutive mornings. Inside the cabin, Tobias kept the fireplace burning constantly. He fed logs into the flames every 2 hours, day and night. The fire roared, filling the stone firebox completely, sending heat into the cabin's single room. Near the fireplace, the air was warm enough that Catherine could cook without her shawl. But 3 feet from the fire, the temperature dropped noticeably. At the cabin's far corners, their breath formed clouds in the air. The floor was the worst. Despite the roaring fire, the packed earth floor remained frozen. Tobias could feel cold radiating up through his boots. At night, when Catherine put the children to bed, she piled every blanket they owned onto the rope frame, trying to create warmth through layers. Gideon and Meredith slept together for shared body heat. Catherine lay between them and the cabin's outer wall, using her body to block the cold that seeped through the logs despite the chinked gaps. Tobias barely slept. He maintained the fire through the night, adding wood whenever the flames diminished. He watched his family shiver under their blankets and felt helpless. The fire was doing everything it should. The problem was that heat rose. The warmest air in the cabin collected near the ceiling and then escaped through tiny gaps in the roof. The coldest air settled at floor level, where his children tried to sleep. On January 4, 1843, Meredith woke with a cough. By evening, she had a fever. Catherine held her close to the fire, but the child shivered uncontrollably. Gideon developed the same cough 2 days later. Tobias rode through brutal cold to fetch supplies from Blackwood's trading post. He returned with what medicine was available, basic remedies that might help or might do nothing. Catherine dosed the children with willow bark tea and kept them as close to the fire as safely possible. For 3 days it seemed Meredith might recover. Her fever broke on January 7th, but Gideon worsened. His small body couldn't generate enough heat to fight both the sickness and the relentless cold. He died on January 9th, 1843, 4 days before his 3rd birthday. Meredith followed on January 11th. Catherine, weakened by grief and exhaustion, developed pneumonia on January 13th. She lasted 5 days. Tobias buried his wife on January 18th in ground he had to thaw with fire before he could dig. The cabin still held his family's possessions, but it no longer held life. The fire still burned, filling the space with heat that rose uselessly toward the ceiling while the floor remained frozen. Tobias spent the week after Catherine's burial in a state that neighbors later described as dangerous. He did not eat. He maintained the fire, but did not seem to notice whether it burned hot or cold. Emmett Pritchard stopped by on January 23rd and found Tobias sitting motionless on the floor near the fireplace, staring at the flames. Emmett tried to talk to him. Tobias did not respond. Other settlers checked on him periodically. They brought food he did not eat. They offered sympathy he did not acknowledge. They assumed grief had broken something fundamental in Tobias Whitlock's mind. They were partially correct. Grief had broken him, but what grew in the broken places was not madness. It was obsession. Tobias could not stop thinking about heat. He lay on the frozen floor of his cabin and felt cold, radiating up through the packed earth into his body. He looked at the fire burning in the stone fireplace and watched heat shimmer upward, toward the roof, toward the sky, toward nothing useful. His family had died 10 feet from a fire that burned hot enough to cook meat and boil water. They had died because the heat went up and they lived down. The unfairness of it consumed him. During the 3rd week of February, Tobias began moving. He started by studying his fireplace with the intensity of a man trying to memorize scripture. He observed how flames pulled air from the cabin and sent it up the chimney. He put his hand near the stonework and felt how the rock absorbed heat, then radiated it into the room. He climbed onto the roof and examined the chimney, noting how heat escaped into the winter air. He began asking questions no one could answer. Where did the heat go after it left the chimney? Could it be captured? Could it be redirected? Could it be used before it escaped into the sky? Most settlers, when faced with cold cabins, simply burned more wood. Tobias began to wonder if the problem was not the amount of heat, but the path it took. Heat rose because hot air was lighter than cold air. This was natural law, unchangeable. But what if the heat could be forced to travel horizontally before it rose? What if it could be made to pass through the floor before escaping? The idea formed slowly over weeks of observation and thought. Tobias had no formal education in physics or engineering. He knew only what he had observed in his 31 years of life. But he knew that brick kilns heated bricks at ground level by making hot air travel through. underground channels before venting. He knew that bakery ovens stayed hot for hours because heat soaked into thick walls before radiating outward. He began to see a solution. Spring came late to Wyoming in 1843. Snow lingered through March. The river ice did not break until mid-April. Tobias emerged from winter like a man waking from fever, thinner and harder than before. He worked his land with mechanical efficiency, planting wheat and vegetables not because he cared about harvest, but because survival required it. His mind was elsewhere. In early May, he rode east to a settlement near Fort Laramie, where a man named Jacob Stern operated a brick-making operation. Stern had emigrated from Pennsylvania 2 years earlier and brought knowledge of commercial brick production. His kiln was the only one within 200 miles. Tobias arrived at Stern's operation on a Tuesday morning and asked if he could watch the kiln operation. Stern, accustomed to curiosity from settlers who had never seen bricks manufactured, agreed. What Stern expected was a few hours of casual observation. What he got was 3 full days of intense study. Tobias watched everything. He observed how Stern loaded wet bricks into the kiln's chamber. He studied the firebox design, noting how flames entered at one end. He paid particular attention to the kiln's underground flue system. The kiln was essentially a large brick dome. Beneath this dome, Stern had built channels that carried heat from the firebox through the entire kiln floor before venting through a chimney on the opposite end. The principle was simple but effective. Hot air and smoke, instead of rising directly up, were forced to travel horizontally through brick tunnels. As the heat traveled, it warmed the bricks from below. By the time the exhaust reached the exit chimney, much of its heat had transferred into the kiln structure and the bricks inside. Tobias asked questions. How wide were the underground channels? 8 inches, Stern answered. How deep were they buried? 6 inches below the kiln floor. What prevented the channels from collapsing? They were built from brick, vaulted in an archbow shape that supported earth above. How long did heat continue radiating from the kiln floor after the fire went out? Hours, sometimes a full day if the firing had been hot enough. Did the system require constant fire to maintain heat? No, Stern explained. One good firing would keep the kiln warm enough to dry bricks for 2 days. The heat, stored in the brick and earth, released slowly. Tobias spent the 3rd day simply sitting beside the kiln, watching how heat moved through Stern's system. He placed his hand on the kiln floor and felt warmth radiating upward. He examined the exit chimney and noted that smoke emerged much cooler than it would from a normal fire. Tobias left Stern's brick operation with a theory forming in his mind. Heat could be forced to travel horizontally through underground channels. Heat, traveling through such channels, would warm the earth and any structure above it. Heat that warmed a floor would radiate upward into a living space. The principle was sound. The question was whether it could be adapted from brick kiln to frontier cabin. In mid-June, Tobias made his annual trip to St. Louis to sell furs he had trapped during spring. The journey took 3 weeks by horseback, following established trails east through the plains. Most trappers looked forward to St. Louis as a chance to drink, gamble, and spend their earnings on entertainment. Tobias had different priorities. He spent his first day in the city locating every bakery, foundry, and industrial operation that used fire for manufacturing. He introduced himself as a settler interested in heating methods. Most operators thought his questions were strange but harmless. A German baker named Otto Kessler showed Tobias his bread ovens, which used a design brought from Bavaria. The ovens featured thick brick walls and a floor system where heat from the firebox traveled through channels beneath the baking surface before exiting. Kessler explained that this design meant he could fire the oven once in early morning and bake bread throughout the day on residual heat. The floor stayed hot for 8 to 10 hours after the fire died. Tobias examined the oven's construction carefully. He noted how Kessler had built the underground channels using fire brick arranged in a curved pattern. The channels were approximately 10 inches wide and 12 inches deep. Clay mortar sealed the joints. Above the channels, a layer of sand provided insulation and distributed heat evenly across the baking floor. At a foundry near the riverfront, Tobias watched workers pour molten iron. He was not interested in the metalwork itself, but in how the foundry managed heat distribution. The facility used a system of brick flues that carried hot exhaust from furnaces through the building before venting outside. A foreman explained that this captured waste heat kept the entire foundry warm during winter. The system required careful engineering to prevent backdraft and ensure proper airflow. Tobias asked about pipe diameter, airflow calculations, and chimney height ratios. The foreman, impressed by the questions, sketched basic principles on a piece of slate. Hot air rises, but it can be channeled horizontally if the path is clear and the exit point is higher than the entry point. Wider channels move more air, but lose heat faster. Narrower channels retain heat, but can become blocked by ash or condensation. Tobias spent 2 weeks in St. Louis, studying heating systems with the intensity of a university student. He filled a small journal with sketches and notes. He measured pipe diameters and channel depths. He asked about materials, construction methods, and failure points. People thought he was odd, this lean frontiersman obsessed with ovens and flues, but they answered his questions. When Tobias left St. Louis in early July, he carried supplies other trappers would have considered wasteful. He had purchased 30 sections of fired clay drainage pipe, each section 2 feet long and 6 inches in diameter. He bought iron bands designed for barrel construction. He acquired 2 bags of lime for mortar. He purchased a small bellows and a set of masonry tools. The total cost consumed most of his fur sale earnings. Other trappers, heading back to the mountains, saw his loaded pack horses and made jokes about Whitlock finally losing his mind completely. Tobias returned to his Wyoming cabin in late July 1843. The wheat he had planted in May stood knee-high. The vegetable garden showed promising growth. His cabin, empty of family, waited exactly as he had left it. He unloaded his supplies and stacked the clay pipe sections carefully inside the cabin. Silas Pemberton stopped by the following morning. Pemberton was Tobias's nearest neighbor, homesteading land 3 miles south. He was a large man, quick to laugh and equally quick to offer opinions on matters he did not fully understand. He had come to welcome Tobias back and see what supplies had been purchased in St. Louis. When Pemberton saw the clay pipe stacked against the cabin wall, his expression shifted from friendly curiosity to concern. He picked up one of the pipe sections, turning it in his hands. "These are drainage pipes," he said. "What are you draining?" Tobias was cutting leather straps to secure his saddle. He did not look up. "I am not draining anything." Pemberton waited for further explanation. When none came, he pressed the question. "Then why did you buy 30 sections of drainage pipe?" "I am going to install them under my cabin floor," Tobias said, "to move heat from the fireplace." Pemberton stared at him. "You are going to dig up your floor?" Tobias nodded. "And bury pipes underneath?" "Yes." "To move heat?" "Yes." Pemberton set the pipe section down carefully. He spoke slowly as a man might speak to someone suffering from sun sickness. "Tobias, heat rises. Everyone knows this. You cannot make heat travel through underground pipes. It will just rise up and escape." "That is the point," Tobias said. "Heat rises, but it can be channeled first. If I force the hot air from my fireplace to travel through pipes under the floor before it exits through a chimney, the pipes and the earth around them will absorb heat. That heat will radiate upward through the floor." Pemberton shook his head. "That is not how heat works. You are wasting money and time on madness. Grief has broken your thinking." Tobias continued working on his leather straps. His voice remained level. "I have seen systems like this in St. Louis. They work. Bakeries use them. Foundries use them. Brick kilns use them." "You are not baking bread," Pemberton said, his voice rising. "You are trying to heat a cabin. "This is different. The principle is the same," Tobias replied. Pemberton left frustrated. Within days, word spread through the scattered settler community. Tobias Whitlock, driven mad by the loss of his family, was planning to tear up his cabin floor and bury drainage pipes underneath. The story grew with each retelling. Some versions claimed he believed he could heat his entire cabin with a single candle. Others suggested he was building an elaborate grave for his wife and children underneath the cabin floor. Emmett Pritchard rode over to check on Tobias in early August. He found Tobias measuring the cabin's interior, making marks on the floor with charcoal. Emmett asked gently if Tobias had truly thought through what he was planning. Tobias showed him the journal from St. Louis, filled with sketches and calculations. He explained the physics of heat transfer, thermal mass, and radiant warming. Emmett listened politely but remained unconvinced. "Even if it works," he said, "you will spend months building something that might give you slightly warmer floors. Is that worth destroying your cabin?" "If it prevents one more family from freezing," Tobias said quietly, "then yes." On August 15, 1843, Tobias Whitlock began dismantling his cabin floor. The floor was packed earth, smoothed and hardened by 3 years of use. Catherine had swept it daily. The children had played on its surface. To neighbors watching from a distance, the act of tearing it up seemed like desecration. Tobias started at the fireplace. He used a mattock to break through the hardened surface, then a shovel to remove loosened earth. His plan required a primary channel running from the fireplace across the cabin's length to a secondary chimney he would build on the opposite wall. This main channel would be 20 feet long. From this primary channel he would dig 4 lateral branches, each extending 8 feet toward the cabin's sides. The pattern would resemble a tree, with the fireplace as roots and branches spreading heat throughout the floor. The work was brutal. The earth beneath the cabin floor was dense, filled with rocks that had to be pried out individually. Tobias worked from dawn until dark, making slow progress. After 3 days, he had excavated a trench 1 foot deep and 10 inches wide, extending 6 feet from the fireplace. Silas Pemberton stopped by on the 4th day. He stood in the doorway, looking at the torn-up floor, the piles of dirt, the destroyed interior. "This is insanity," he said. "You had a functional cabin. Now you have a construction site. Winter will be here in 3 months. What if you do not finish?" "Then I will sleep in a cabin with trenches in the floor," Tobias said, continuing to dig. Pemberton left, shaking his head. That evening, Emmett Pritchard arrived with his wife, Mary. They brought a basket of food and genuine concern. Mary looked at the destruction and began crying softly. "Tobias," she said, "this is not healthy. You are tearing apart your home. You need to stop and think clearly." "I am thinking clearly," Tobias said. "For the first time since January, I am thinking clearly." "But you are destroying everything," Emmett protested. "The cabin was fine." "It was not fine," Tobias said, his voice harder. "It was a death trap. It looked like shelter, but it killed my family anyway. I will not let it kill anyone else." The Pritchards left, troubled. Word spread further. Settlers began using Tobias's name as a cautionary tale. "Grief can break a man's mind," they said. "Look at Whitlock tearing up his own floor because he cannot accept that winter killed his family." By early September, Tobias had completed the main channel and 2 of the lateral branches. His cabin looked like a battlefield. Dirt piles stood everywhere. Trenches crisscrossed the floor. The structure remained sound, but the interior was chaos. Tobias did not care what others thought. He had calculations to follow and a system to build. The mockery meant nothing compared to the work. Tobias worked from principles he had observed rather than formal engineering knowledge. He understood that hot air would travel through his underground channels only if certain conditions were met. The exit chimney had to be higher than the fireplace entrance. The channels had to slope gradually upward to prevent air from pooling. The pipe diameter had to balance airflow against heat retention. Too wide, and heat would escape before warming the earth. Too narrow, and the system would choke on its own smoke. He calculated the optimal pipe diameter through trial and observation. At Stern's brick kiln, the underground channels had been 8 inches wide. Kessler's bakery ovens used 10-inch channels. Both systems moved large volumes of hot air quickly. Tobias's cabin was smaller. He needed heat to move slowly, transferring warmth to surrounding earth before exiting. He decided on 6-inch diameter pipes. The clay sections he had purchased from St. Louis matched this specification perfectly. The slope calculation required more thought. Tobias knew that water would flow through a pipe sloped at 1 inch per 10 feet. Hot air was lighter than water and more eager to rise. He estimated he could use a gentler slope, perhaps 1 inch per 20 feet. His main channel ran 20 feet from fireplace to exit chimney. A 1-inch rise over that distance would create sufficient draft without rushing air through too quickly. He measured and marked the cabin floor accordingly. The lateral branches presented a different problem. These channels would extend perpendicular to the main trunk, carrying heat toward the cabin sides. But they would end in closed caps, not exits. Would hot air travel into dead-end channels? Tobias reasoned that it would, driven by pressure from air behind it and by the fact that the closed ends would be warmer than outside air, creating convective circulation. The earth surrounding these branch channels would absorb heat and radiate it upward. He decided the branch channels should be slightly narrower than the main trunk to slow air movement and increase heat. Transfer. He would use 5-inch diameter sections for the lateral branches. The depth of burial mattered significantly. Bury the pipes too shallow, and heat would escape through the cabin floor too quickly, potentially making the surface uncomfortably hot. Bury them too deep, and the earth would insulate the pipes, preventing heat from reaching the living space. Stern's kiln buried channels 6 inches below the floor surface. Kessler's ovens used 8 inches. Tobias split the difference, deciding on 7 inches of earth cover above his pipes. This would place the pipe tops 13 inches below the original floor surface, accounting for the 6-inch pipe diameter. The exit chimney required careful positioning. Tobias planned to build it on the cabin's north wall opposite the fireplace. The chimney top would extend 3 feet above the roofline, creating draft. The base would connect to the main underground channel. Between the underground exit and the above-ground chimney, he would build a vertical stone shaft similar to his fireplace chimney, but narrower. He sketched these calculations in his journal. The drawings were crude but functional. He had no formal training, but he understood the principles well enough to build something that should work. Whether it would work remained to be proven. By mid-September, Tobias had excavated all 5 trenches. The main channel ran straight from fireplace to the north wall. 4 lateral branches extended perpendicular, 2 on each side of the main trunk, spaced to distribute heat evenly across the cabin floor. The trenches resembled a crude map of veins spreading through the earth. Each trench measured 10 inches wide at the top, tapering to 8 inches at the bottom. The depth varied according to his slope calculations, ranging from 12 inches deep at the fireplace end to 13 inches at the exit chimney location. The earth removed from these trenches filled one corner of his cabin in a massive pile. Tobias would use this soil later for backfill. Before installing pipes, Tobias addressed drainage. Underground channels carrying hot smoke would produce condensation as hot air met cold earth. Water would form inside the pipes and needed somewhere to go. If it pooled, it would block airflow or freeze during winter, destroying the system. Tobias's solution was elegant. He dug small sumps at the lowest point of each lateral branch, extending 6 inches deeper than the main channel floor. These sumps would collect condensation, allowing it to seep into the earth below rather than filling the pipes. In the main channel, he created a gentle, continuous slope that would drain any moisture toward the exit chimney where it could evaporate. He lined each trench bottom with a 2-inch layer of coarse sand. The sand served multiple purposes. It provided a level base for pipes, allowed drainage, and would help distribute heat evenly. He had hauled the sand from a creek bed 2 miles away, carrying it in leather bags over 3 trips. Installing the pipes required precision. Each clay section was 2 feet long with a socket joint on one end and a tapered spigot on the other. Sections fitted together by inserting the spigot into the socket of the previous section. Tobias started at the fireplace. He had modified the firebox by creating an opening at the back, low and to one side, where the first pipe section would connect. He built a clay collar around this opening, creating a sealed transition from firebox to pipe. The first pipe section angled down slightly as it left the fireplace, beginning the gradual slope toward the exit. Tobias fitted the second section to the first, checking alignment carefully. The joints had to be sealed against air leaks. He mixed mortar using clay, lime, and fine sand, creating a thick paste. He packed this mortar around each joint, smoothing it carefully. Air escaping through gaps would reduce system efficiency and could fill the cabin with smoke. Each section had to be perfectly aligned. Tobias used a level and straight edge, adjusting pipe position in the sand bed until the slope matched his calculations. The work was slow. By evening of the first installation day, he had placed only 8 sections, covering 16 feet of the main channel. The 4 remaining feet would connect to the exit chimney, which he had not yet built. Tobias spent the next week completing the pipe installation. The main channel required 15 sections to span from fireplace to the north wall. Each joint was sealed with his clay lime mortar. He allowed the mortar to dry for a full day before proceeding, ensuring each connection was solid. The lateral branches were more complex. Each branch required 6 pipe sections to extend 8 feet from the main trunk. But the branches did not draw air from the fireplace directly. Instead, Tobias created openings in the main trunk pipe by carefully cutting slots in the clay sections where branches would connect. These openings were 4 inches in diameter, small enough to maintain good airflow in the main channel while allowing hot air to spill into the lateral branches. Cutting the clay pipes without shattering them required patience. Tobias used a small hacksaw, working slowly to score the clay before tapping gently with a mallet to break through. He created 4 branch openings spaced evenly along the main trunk. At each opening, he built a wide junction using clay and mortar, connecting the branch pipe to the main channel. The branch pipes extended outward and terminated in clay caps he had fashioned himself. These caps sealed the branch ends while allowing heat to radiate through the clay into surrounding earth. The iron bands he had purchased in St. Louis served as reinforcement at critical junctions. Tobias wrapped bands around the Y connections where branches met the main trunk, then secured them with wire. The bands prevented the hand-formed clay junctions from cracking under thermal stress when hot. Air began flowing through the system. By late September, all pipes were installed. The underground network lay complete in its trenches, waiting to be buried. Tobias performed a test before backfilling. He built a small fire in the fireplace and watched smoke behavior. Initially, smoke simply rose up the main chimney as it always had, but when he partially blocked the main chimney with a board, forcing air to find another path, smoke began flowing into the underground channel. He could not see the smoke in the buried pipes, but he walked to the north wall where the exit chimney would be built. Smoke emerged from the open pipe end, confirming that air was traveling through the entire system. The test revealed a problem. Smoke also leaked from several joints where his mortar had not sealed completely. Tobias spent 2 days repairing these leaks, applying additional mortar and allowing it to cure. He tested again. This time, smoke flowed through the underground channel without significant leakage. Satisfied with the pipes, Tobias began backfilling. He did not simply dump earth back into the trenches. Instead, he used sand for the first 4 inches of cover directly over the pipes. Sand would conduct heat better than clay soil and would not hold moisture against the clay pipes. Above the sand layer, he replaced the original earth, packing it firmly but not so densely that it would prevent heat radiation. The backfilling process took a full week. Tobias worked methodically, filling each trench in layers and tamping the earth to prevent settling. He left small access hatches at 3 locations. These hatches were simple wooden boxes sunk into the floor with removable covers. They allowed him to inspect the pipes and clear any blockages without excavating the entire floor. By early October, the cabin floor was restored. The surface looked nearly as it had before Tobias began his project, though slightly higher due to the added pipe infrastructure below. Tobias smoothed the earth, wetting it and tamping until it hardened. He considered installing wooden planks over the entire floor, but decided against it initially. He wanted to observe how heat radiated through bare earth before adding another layer. The exit chimney remained to be built. This structure would carry smoke from the underground channel up through the roof and into open air. Tobias gathered stones from the creek bed and began construction on the cabin's north wall. He built the chimney's base around the pipe exit, creating a sealed chamber where underground smoke would enter before rising. The chimney interior measured 8 inches square, smaller than his main fireplace chimney, but adequate for the reduced smoke volume after heat had been extracted underground. He built the chimney using the same river rock and clay mortar technique he had used for the fireplace. The structure rose through the cabin wall, requiring him to cut an opening in the logs. He sealed carefully around the stonework to prevent drafts. The chimney continued up the exterior wall and extended 3 feet above the roof line. At the top, he created a simple cap to prevent rain from entering while allowing smoke to escape. The construction took 5 days. When finished, Tobias had 2 chimneys on his cabin, the main fireplace chimney on the south wall and the new exit chimney on the north wall. To neighbors who occasionally passed by, the dual chimney configuration looked strange and unnecessary. The final element was a damper system. Tobias needed to control how much smoke traveled through the underground channels versus how much escaped directly up the main fireplace chimney. He fabricated a simple iron plate that could slide across the main chimney throat, partially blocking it and forcing more smoke into the underground system. The plate could be adjusted from inside the cabin using an iron rod. When fully open, the system would operate like a normal fireplace. When partially closed, it would force most exhaust through his underground heat distribution network. On October 12, 1843, Tobias Whitlock stood in his rebuilt cabin and surveyed what he had created. The floor looked normal. The fireplace appeared unchanged except for a small opening at the back where pipes connected. The exit chimney rose on the north wall, functional and properly sealed. The entire system was complete. Whether it would work as theorized remained unknown. October 13th dawned cold and clear. Overnight temperatures had dropped to 20 degrees. Inside the cabin, Tobias could see his breath in the still air. He had not lit a fire since completing the system, wanting to start with a complete test rather than gradual trials. He prepared carefully. He cleaned ash from the firebox and inspected the damper mechanism one final time. He checked the exit chimney exterior, ensuring no debris blocked the opening. He opened the small access hatches in the floor to observe the underground pipes directly. Everything appeared ready. At mid-morning, Tobias built a fire. He started with kindling and small branches, establishing flames before adding larger wood. The fire caught easily. Smoke rose up the main chimney as it always had. The cabin began warming in the familiar pattern, heat radiating from the firebox into the immediate area. Tobias waited until the fire burned hot and steady, then he reached for the damper rod and slowly closed the main chimney throat halfway. The effect was immediate. Smoke that had been rising freely now encountered resistance. It swirled in the firebox, seeking escape. Within seconds, smoke began flowing through the opening at the back of the firebox, entering the underground pipe system. Tobias moved to the first access hatch and peered down. He could see heat shimmer in the air above the buried pipe. He could not see smoke moving through the clay sections, but he could hear a soft, rushing sound as hot air traveled through the channel. He walked to the north wall where the exit chimney rose. Smoke emerged from the top, flowing steadily upward. The system was functioning. Hot exhaust from the fireplace was traveling 20 feet through underground pipes before venting to the atmosphere. Tobias closed the damper further, forcing more smoke into the underground system. The fire responded by burning hotter, drawing harder to pull air through the restricted chimney. He found a balance point where the damper was 3/4 closed. At this setting, most smoke traveled underground, while enough escaped through the main chimney to prevent backup into the cabin. He maintained the fire through the afternoon, adding wood regularly. After 2 hours, he knelt and placed his palm on the cabin floor. The earth was noticeably warm, not hot enough to burn, but distinctly warmer than it had been. He checked different locations. Directly above the main channel, the floor was warmest. Above the lateral branches, heat was less intense, but still present. In areas without pipes below, the floor remained cool. By evening, the temperature difference was dramatic. Tobias walked barefoot across his floor and could trace the underground pipe pattern by feel alone. Where pipes ran below, the earth radiated gentle warmth. His feet, which would normally be cold on frozen ground, were comfortable. He let the fire burn through the night, maintaining steady heat. By morning of October 14th, the cabin floor had become a radiant heating surface. The warmth rising from below changed the entire cabin's temperature profile. Instead of heat collecting near the ceiling, the warmth started at floor level and filled the space evenly. November brought the first serious cold. Temperatures dropped into the teens at night, rising only to the 30s during daylight hours. Light snow fell intermittently. Settlers throughout the territory began their annual preparations for winter, stockpiling firewood and sealing cabins against drafts. Tobias maintained his underground heating system, learning its characteristics through daily use. He discovered that the system responded slowly to changes. When he built up the fire, the floor did not warm immediately. Heat took 30 to 40 minutes to travel through the pipes and saturate the surrounding earth. But once warmed, the floor retained heat for hours. He could let the fire die to coals at bedtime, and the floor would remain warm until morning. He learned to manage the damper setting. Fully closed created too much back pressure and filled the cabin with smoke. Fully opened sent heat up the main chimney, defeating the system's purpose. The optimal setting was approximately 70% closed, forcing most exhaust underground while maintaining adequate draft for the fire to burn cleanly. Wood consumption was lower than previous winters. The efficient heat capture meant Tobias burned roughly 30% less firewood to maintain comfortable temperatures. Heat that previously escaped up the chimney now warmed his living space. By early December, word had spread that Tobias's strange heating system apparently functioned. Settlers who had mocked him now expressed cautious curiosity. A few stopped by to see the dual chimney configuration and ask questions. Tobias explained the principles willingly, but did not push anyone to adopt his methods. December brought colder weather. By mid-month, nighttime temperatures regularly reached 0 or below. This was when the system's true value became apparent. Other cabins required constant fire maintenance. Settlers woke multiple times per night to add wood, fighting to keep interior temperatures above freezing. Their floors remained frozen solid. Children slept in layers of clothing under piled blankets. Tobias's cabin told a different story. He maintained a moderate fire, nothing excessive. The underground pipes distributed heat throughout the floor. The warmed earth radiated heat upward continuously. The cabin's interior temperature remained steady at 60 to 65 degrees. The floor itself stayed between 70 and 75 degrees, warm enough to walk on comfortably without boots. He could sleep through the night without tending the fire. The system's thermal mass carried heat for 6 to 8 hours after flames died to coals. Morning fires were smaller, just enough to replenish heat rather than fighting extreme cold from scratch. On December 18th, the temperature dropped to 15 below zero overnight. Tobias woke in a cabin that felt comfortable. He walked barefoot to the fireplace and built a small fire. Within an hour, the cabin was warm enough that he worked in shirt sleeves. Outside, the Wyoming winter held the land in brutal cold. Inside, Tobias lived in conditions that would have seemed impossible the previous year. His family had died in temperatures like this. Now he survived comfortably, using principles they had never known. Silas Pemberton arrived at Tobias's cabin on December 20th. The visit was ostensibly a neighborly check during harsh weather, but Pemberton's real motivation was curiosity. He had heard reports from other settlers about Whitlock's warm cabin. He needed to see for himself whether the stories were true or exaggerated. Pemberton knocked and entered when Tobias called out. The difference hit him immediately. Outside, the temperature held at 10 below zero. Pemberton wore heavy wool coat, fur hat, thick gloves, and insulated boots. His face was red from cold. His breath formed dense clouds in the frozen air. Inside Tobias's cabin, the air felt warm enough to be comfortable. Pemberton's eyes adjusted to the interior dimness. He saw Tobias standing near the table, wearing only a cotton shirt and canvas work pants. No coat, no blanket around his shoulders. And most startling, Tobias was barefoot. Pemberton stared at Tobias's bare feet on the cabin floor. "How are you not freezing?" he said. The question came out sharper than intended, driven by genuine confusion. Tobias gestured to the fireplace where a modest fire burned. "The floor is warm," he said simply. "Walk on it." Pemberton did not move immediately. The statement seemed impossible. Cabin floors in winter were frozen. Everyone knew this. "You cannot have warm floors in December," Pemberton said. Tobias walked across the cabin, his bare feet moving normally over the earth floor. He stopped near Pemberton. "Touch the floor. Prove it to yourself." Pemberton hesitated, then removed one glove and knelt. He placed his palm on the packed earth floor. The surface was warm, not slightly warm, not tepid, genuinely warm, like sun-heated stone in summer. He moved to a different location and touched again. Warm. He walked to the far corner and tested. Still warm, though slightly less intense than near the fireplace. He stood slowly, trying to reconcile physical evidence with his understanding of how cabins worked. "This is not possible," he said. "Heat rises. Floors cannot be warm. The heat travels under the floor before it rises," Tobias explained. "The pipes I buried carry hot air from the fireplace across the cabin and out through the north chimney. As the hot air travels underground, it warms the earth. The warmed earth radiates heat upward." Pemberton looked at the floor with new understanding. "The entire floor is heated?" "Most of it," Tobias confirmed. "The areas directly above the pipes are warmest, but heat spreads through the earth, so the whole floor stays above freezing." Pemberton removed his other glove and his heavy coat. The cabin's warmth made the winter clothing unnecessary. He sat on Tobias's chair, still processing what he was experiencing. "You were right," Pemberton said quietly. "I mocked you. I told others you had gone mad, but this works. This actually works." Tobias added a log to his fire. The fire was small compared to the roaring blazes most settlers maintained. "I am burning less wood than you are," Tobias said, "and staying warmer." Emmett Pritchard's cabin stood 4 miles northeast of Tobias's land. Emmett lived there with his wife Mary and their 3 children, Samuel, aged 8, Rebecca, aged 6, and Thomas, aged 3. The family had settled in Wyoming 2 years earlier and had survived one winter adequately. The current winter was proving more difficult. By early January 1844, all 3 Pritchard children were sick, not severely ill, but suffering from persistent coughs and low fevers that would not resolve. Mary kept them close to the fire constantly, but the cabin's temperature remained barely above freezing, except within a few feet of the flames. The children slept together under every blanket the family owned, but woke each morning shivering and miserable. Emmett burned wood frantically, feeding the fire day and night. His carefully stockpiled firewood was disappearing faster than he had planned. At the current consumption rate, he would run out by late February, leaving 6 weeks of winter with insufficient fuel. On January 7th, Rebecca's cough worsened significantly. She developed a high fever and began having trouble breathing. Mary dosed her with willow bark tea and kept her wrapped in blankets near the fire, but the child's condition deteriorated. By January 9th, Emmett faced the reality that his daughter might die if conditions did not change. That morning, he rode to Tobias's cabin through bitter cold. He arrived mid-morning and knocked urgently. Tobias opened the door and saw Emmett's desperate expression immediately. "Rebecca is very sick," Emmett said without preamble. "She cannot get warm. Our cabin is freezing. No matter how much wood I burn, I need help." Tobias invited him inside. Emmett stepped into warmth that made him want to weep. The contrast between his frigid cabin and Tobias's comfortable space was devastating. "I need you to teach me," Emmett said. "I need to build what you built. I do not care if it takes weeks. I do not care if people think I am crazy. My children are suffering." Tobias did not hesitate. "We start today," he said. "The construction would take time." Emmett did not have if Rebecca was critically ill. Tobias made a quick decision. "Bring your family here," he said. "They can stay in my cabin while we build your heating system. Your children will be warm and safe. Mary can tend Rebecca here. We will work on your cabin during daylight hours." Emmett's relief was visible. Within 2 hours, the Pritchard family had relocated to Tobias's cabin. Mary settled the children near Tobias's fireplace, spreading blankets on the warm floor. The children, accustomed to sleeping on frozen ground, were astonished by the heated surface. Rebecca's breathing eased almost immediately in the warmer air. Tobias and Emmett rode to the Pritchard cabin and began planning. The structure was similar to Tobias's, slightly smaller at 14 feet by 18 feet. Tobias sketched a pipe layout adapted to the reduced size. 1 main channel, 3 lateral branches. They would need fewer pipes, but the same principles would apply. Winter progressed through January and February of 1844, with brutal cold that tested every settler's preparation and resolve. The Pritchard family remained healthy in their newly heated cabin. Rebecca recovered fully within 2 weeks of the system's completion. Other children in the territory were not as fortunate. Pneumonia and cold-related illnesses moved through the scattered homesteads, taking lives with grim regularity. By late February, 9 settlers had stopped by Tobias's cabin to ask questions about his heating system. Most came hesitantly, embarrassed by their earlier mockery, but driven by genuine need. Tobias received them without judgment and explained the principles patiently. He showed them his pipe layout, demonstrated the damper mechanism, and walked them through the construction process. Some took notes. Others simply observed and asked questions. In March, as weather began, moderating slightly, construction started on 4 new underground heating systems. Tobias helped where he could, offering advice and occasionally lending tools. Each builder adapted the basic design to their specific cabin dimensions and available materials. A trapper named William Foster built his system using hollowed logs instead of clay pipes, sealing them with pitch and clay. The system worked adequately, though not as efficiently as fired clay. A Norwegian settler named Henrik Larsen created a variation that used a single, long spiral channel instead of the branching pattern Tobias had designed. Larsen's floor heated less evenly but required fewer materials. The important principle, heat distribution through underground channels, proved adaptable to different implementations. Silas Pemberton began his construction in early April. He came to Tobias first, hat literally in hand, and apologized formally for his mockery and doubt. Tobias accepted the apology simply and spent 3 days helping Pemberton excavate trenches and plan his pipe layout. Pemberton's cabin was larger than most, requiring an extended network of channels. The construction took 5 weeks, but produced exceptional results. By May, 7 cabins in the Wyoming Territory had underground heating systems. News traveled beyond the immediate area. Trappers and traders carried stories of Whitlock's warm floors to other settlements. Some listeners dismissed the accounts as exaggeration. Others filed the information away for future consideration. Owen Blackwood, who operated the trading post 40 miles east, heard multiple versions of the story from different sources. In June, he rode to Tobias's cabin specifically to investigate. Blackwood was a practical businessman. He dealt in supplies and information, always looking for opportunities. He examined Tobias's system carefully, asked detailed questions about materials and construction methods, and walked through the physics with genuine interest. "This could change how people build on the frontier," Blackwood said. "Winter kills more settlers than Indians or accidents. A heating system that actually works could save lives." Tobias agreed, but offered no commercial ambitions. He had built his system to survive, not to profit. Blackwood saw different possibilities. When he returned to his trading post, he began stocking clay drainage pipes, lime for mortar, and iron reinforcement bands. He created a simple instruction sheet based on Tobias's design and offered it free to anyone interested. Owen Blackwood's trading post served settlers across a 200-mile radius. Trappers, homesteaders, and travelers stopped there for supplies, information, and occasionally medical assistance. Blackwood had operated the post for 12 years and understood frontier economics. Products that solved real problems sold reliably. Luxuries did not. Underground heating systems solved a real problem. By summer of 1844, Blackwood had committed significant capital to supporting their construction. He ordered 200 sections of clay drainage pipe from a manufacturer in St. Louis. He stocked lime iron bands and masonry tools. He trained his 2 employees to answer basic questions about system design and installation. When settlers arrived seeking supplies for standard cabin construction, Blackwood mentioned the heating systems. He showed them the instruction sheet and explained the benefits. Warmer cabins, lower wood consumption, better health outcomes for children. Some settlers remained skeptical. Others were convinced by reports from those who had already built systems. Blackwood did not push hard. He simply made information and materials available. By autumn of 1844, 17 cabins across the territory had underground heating systems, either completed or under construction. The number grew through word of mouth and practical demonstration. Settlers who visited heated cabins became convinced. Those who spent a winter in traditional frozen cabins while neighbors stayed comfortable often began construction the following spring. The systems were not universally adopted. Many settlers lacked the time, materials, or skill to excavate floors and install pipes. Some remained skeptical despite evidence. Others simply accepted cold cabins as inevitable frontier hardship. But a significant minority recognized value and committed to the construction effort. Blackwood began offering installation assistance for a fee. He hired 2 men who had built systems for their own cabins to work as consultants during winter months when other work was scarce. These men would travel to a homestead, help plan the pipe layout, assist with excavation, and ensure proper installation. The service cost $20. Expensive by frontier standards, but worthwhile for families who lacked construction experience. Through this consulting service, another 30 systems were built during 1845 and 1846. The installation spread beyond Wyoming into Montana and Idaho territories. Variations developed based on local materials and builder preferences. Some used stone channels instead of clay pipes. Others created systems with centralized manifolds feeding multiple floor zones. A few ambitious builders created 2-story cabins with heated floors on both levels. The core principle remained constant. Capture waste heat from fireplaces and chimneys, route it through underground channels, warm the floor from below. The engineering was simple enough that competent builders could implement it without specialized knowledge. By 1847, Blackwood estimated that over 80 cabins in the northern Rocky Mountain region used underground heating. The actual number was likely higher, as many builders created systems without purchasing materials from his trading post. The innovation had spread organically, carried by satisfied users, and practical demonstration. Tobias. Whitlock never remarried. He lived alone in his cabin for 6 more years after completing the heating system. He continued trapping and farming, maintaining a solitary but functional existence. Neighbors remained respectful but distant. Tobias had changed after his family's death, becoming quieter and more withdrawn. The obsessive energy that had driven his innovation faded once the system was complete and proven. In 1849, Tobias sold his Wyoming land to a young couple from Ohio. He explained the heating system's operation carefully, showed them the access hatches and damper mechanism, and provided detailed instructions for maintenance. The couple, grateful for the improved cabin, offered to pay extra for the installation. Tobias refused additional money. The system was part of the cabin, not a separate commodity. He moved west to the Oregon Territory, seeking distance from memories that would not fade. He purchased land in the Willamette Valley and built a small house, standard construction without underground heating. The Oregon climate was milder than Wyoming. Extreme heating systems were unnecessary. He lived there quietly until his death in 1868 at age 57. His Oregon neighbors knew him as a reserved man who farmed competently and kept to himself. Few knew about his Wyoming years or the innovation he had developed. But in Wyoming, Montana, Idaho, and beyond, cabins with warm floors continued serving families through brutal winters. By 1850, the systems were common enough that they no longer seemed remarkable. New settlers arriving in the territory often found cabins already equipped with underground heating and assumed this was standard frontier construction. The technique became known by various names. Some called them Whitlock floors after Tobias. Others used terms like buried flue cabins or underfloor heating. A few settlers claimed to have invented the systems independently, and perhaps some had through parallel discovery. The specific attribution mattered less than the practical reality. Children slept warm on winter nights. Families survived cold that would have killed them in traditional cabins. Wood supplies lasted longer, reducing the desperate fuel gathering that had consumed so much frontier labor. The systems were not perfect. Pipes occasionally cracked and required repair. Some installations were poorly designed and worked inadequately. A few cabins experienced chimney fires when builders failed to seal joints properly. But overall, the innovation succeeded. It solved a real problem using available materials and practical engineering. It spread through demonstration rather than marketing. It saved lives through multiple decades of frontier settlement. Modern historians examining homestead records note a measurable decline in winter mortality in regions where underground heating systems were adopted. The effect was not dramatic enough to be obvious in individual settlements, but showed clearly in aggregate data across the territories. Families living in heated cabins experienced roughly 30% fewer cold-related deaths than those in traditional structures. The innovation eventually became obsolete. By the 1870s, manufactured iron stoves were widely available and provided more efficient heating than fireplace-based systems. By the 1890s, many frontier cabins were being replaced by frame houses with modern heating. The underground pipe systems were gradually abandoned as old cabins deteriorated or were torn down. But the principle Tobias Whitlock had proven remained valid. Waste heat could be captured and redistributed. Floors could be warmed from below. Intelligent engineering could solve problems that seemed inevitable. The legacy was not in monuments or written records. It existed in warm floors that kept families alive through winters that would have killed them otherwise.